So today we're tackling a scenario that, well, it demands we move past the common images of destruction and really focus on the cold science of a global collapse.
Yeah, it's a heavy topic.
It is. We're talking about a massive nuclear war, not some theoretical idea, but the scenario you asked us to analyze. Dozens, maybe even hundreds of nuclear warheads all detonating across the world on a single day.
Right.
And our mission for this deep dive is, I think, pretty crucial. We need to look beyond the blast itself, the shockwave and the fire that we all imagine. We need to dissect the cascading effects that these climate models predict.
And that distinction is just so important. Most people, when they think of nuclear war, they focus on that localized violence, the city vanishing.
Sure, the immediate horror.
Exactly. But what the source material shows again and again is that the initial explosion, as awful as it is really just the overture. The biggest threat, the one that defines the future for anyone left, is this long-term climatic shift scientists call radiological winter.
Okay, let's unpack that. Radiological winter. How does an explosion on the ground, even a huge one, translate into a climate disaster that locks down the entire planet? What's the actual mechanism?
It all starts with fire.
Hmm.
But, I mean, fire on a scale that's almost impossible to comprehend.
Not just a normal fire.
No. Every warhead that hits an urban center, a place full of concrete, asphalt, plastics, wood, it ignites what's called a firestorm.
Right.
These aren't just fires. They are colossal, self-sustaining infernos. They create their own wind, pulling in oxygen from miles around, which just makes them hotter and more intense.
So the key isn't just the bomb itself, but what it sets on fire,
Yeah.
the sheer volume of city stuff that's burning.
Precisely. It's all about the smoke that's produced. These mega firestorms pump millions of tons of dense, black, sooty smoke, what scientists call carbonaceous smoke, and the heat is so intense it pushes it up fast.
And it doesn't just hang in the lower atmosphere where we live.
No, and this is the most critical part. It doesn't say in the troposphere, where our weather is.
Which means rain can't wash it out. That's the terrifying detail, isn't it?
It is the single most terrifying detail. The smoke column is so powerful, it punches right through that boundary, the tropopause, and gets into the stratosphere.
Which is, what, 10 to 30 miles up?
Up there, yeah. And in the stratosphere, the air is incredibly stable. There's no rain, no weather to bring it down.
So once that soot hits the stratosphere, it's essentially locked in. It's in a stable, long-term orbit around the Earth, acting like a global shade cloth.
That is a perfect way to put it. The sources were very clear on this. Once that layer of soot stabilizes up there, it can stay there, circling the globe, for a decade or even longer. It's not a local problem anymore. It becomes a global one.
If we have this permanent shade across the whole planet, the direct question is, how much sun actually gets through? Does the sun effectively just disappear?
For plant life, for surface temperatures, yes, it effectively does. The blockage is staggering.
What do the numbers say?
The data points suggest that the amount of sunlight reaching the surface will drop by a dramatic 70 to 90%.
To 70 to 90%. That's,
Yeah.
I mean, to picture that, you're talking about turning a sunny afternoon into something like a deep perpetual twilight.
Or darker. And this isn't for a few hours like an eclipse. This is for years.
And the climate's response to that would be immediate.
Immediate and severe. That kind of sunlight blockage triggers a rapid, deep cold. Global average temperatures could fall by 50 degrees Fahrenheit inside the continents. You're talking about plunging the planet into conditions not seen since the last ice age. That's the global deep freeze.
It sounds like a complete ecological breakdown. What happens to life on the ground when you turn out the lights and crank the thermostat down for, say, half a decade?
It's an immediate catastrophe for the entire global food system. Without sunlight and warmth, photosynthesis, basic plant growth, it just slows to a near halt.
So all the major grain belts, the world's bread baskets, they just become useless.
Completely unviable, farms die. It's not just the cold, it's the darkness.
So when you look at the complete stop of all major agriculture, the first thing that comes to mind is just devastating global famines.
And famine is almost too mild a word for what would happen. The scientist predicts something far more systemic.
Which is?
A complete collapse of the food chains. It's not just about us running out of stored grain. It's the entire ecosystem breaking down at the same time.
How so?
Well, think about the oceans. The cooling and the darkness would devastate the phytoplankton on the surface, and that's the very bottom of the entire ocean food web.
So the oceans stop producing food, and the land stops producing food. This global reach is what makes it a civilization-ending event then. It doesn't matter who fired the first missile.
Absolutely. That is the critical takeaway here. The consequences completely ignore political borders, even countries that were nowhere near the fighting.
Neutral countries, nations in the Southern Hemisphere?
They all suffer the same ecological collapse because our climate system is interconnected. If the world's breadbaskets fail, everyone, everywhere, starves.
We focused a lot on the climate, the cold, the dark, the starvation. But that's assuming survivors don't also have to deal with the other major disaster, the invisible threat of radiation.
Exactly. And you really have to separate the two types of radiation threats here.
Okay.
First, you've got the intense, immediate radiation right near the blast sites. That's called prompt radiation. It kills very quickly, within days. But its effects are, localized.
But the sources really emphasize the longer-term danger, the one that lingers long after the fires are out.
And that's the nuclear fallout. Fallout is all the radioactive debris, tiny particles of dirt and vaporized material that get shot up into the atmosphere. They're coated with radioactive isotopes, and then the winds spread them over huge distances before they settle back to Earth.
What makes that dust so dangerous, and for how long?
It's all about the half-life of certain isotopes. People hear about iodine-131, but that's short-lived. The real generational threat comes from things like cesium-137 and strontium-90.
And their half-life is?
Around 30 years. Which means major agricultural areas, water sources, they can stay dangerously contaminated for generations, decades, centuries even. They'd be uninhabitable, unusable for farming long after any war was over.
So survivors are facing a cold, dark world where starvation is almost a guarantee, and any land that might be usable is also increasingly toxic.
That's compounding disaster. The climate collapse guarantees a massive loss of life from starvation, and the fallout contamination ensures that recovery, even for tiny pockets of survivors, is almost impossible. The clean land and water they'd need are just gone.
And this is where the information in the sources shifts from, overwhelming to genuinely shocking. We tend to imagine this requires the full might of global arsenals, thousands and thousands of weapons. But how much does it actually take to flip that switch?
This is the most crucial, staggering piece of data, the one thing that should really stick with you. The source confirms that just 1% of the world's current nuclear arsenal is enough to get the necessary amount of foot into the stratosphere and trigger a global radiological winter.
Just 1%. That's the threshold. Why? Why is that enough? Is it about the size of the bombs or where they're aimed?
It's all about the targeting and the smoke it produces. You don't need the biggest ICBMs. You just need to target dense, flammable urban areas where you're guaranteed to create those firestorms.
So a smaller conflict could do it.
A regional conflict between two smaller nuclear powers, using maybe 50 to 100 warheads on cities, is enough to create the stratospheric smoke layer needed to block 70% of the sun, globally.
That dramatically lowers the bar for a global disaster. It makes the risk feel much more immediate and quantifiable.
It does. And it forces you to ask about our current reality, right? The planet currently has over 12,000 nuclear warheads that are classified as ready for use.
12,000.
12,000 tools for ending civilization. And we only need 1/100th of that total, maybe fewer than 100 actual strikes on cities, to trigger the whole system's collapse.
So what does this all mean in terms of human risk? It kind of transforms this abstract idea of global conflict into a question of mechanical fragility.
It brings the abstract risk into razor-sharp focus. The discussion in the source concludes with the assertion that humanity is, and I'm quoting here, literally holding the button of the end of the world.
Wow.
This knowledge is why scientists are so vehemently against any kind of global escalation. They understand that a single nuclear mistake, one regional conflict, could cascade through the climate system and mean the end of civilization within weeks, not because of the bombs, but because of the cold and the dark that follow.
So if you take one key thing away from this deep dive, it has to be this. The long-term climate-driven collapse, the radiological winter, the darkness, the cold, the destruction of the food chain, that is the truly devastating consequence of a nuclear exchange. It's so much bigger than the bombs themselves.
It is. It's not the initial blast that kills most of humanity in this scenario. It's the systemic failure triggered by the dark and the cold.
A truly chilling thought.
Absolutely. And for a final thought to ponder, just reflect on the incredible fragility that 1% figure implies. The idea that such a small fraction of our weapons, fewer than 100 bombs, can permanently shatter the planet's climate stability is, it's an astonishing measure of the risk we live with.
And it could happen so quickly?
Within weeks. A single nuclear error could unravel civilization entirely, simply by plunging the global ecosystem into a darkness and cold from which there is no quick escape. It really forces you to see international stability not as a political goal, but as an existential requirement for the survival of our species.